Welcome. This is Coach Dorf. We're in section 5.4 and we're looking at a homework example. In this example, we have an oil storage tank that ruptures and leaks oil. And we're asked to answer two questions about this. Some background, let's review a little bit here. First of all, if x equals a function that represents a certain quantity, then we know that the derivative of that equals the rate of change of that quantity, because we often think of the derivative as the slope of the tangent line, but it's also the rate of change of a quantity. That's the first point. The second point is, by the fundamental theorem of calculus, part 2, we know that the integral from a to b of f prime of x dx is going to equal f of b minus f of a. Because f prime, then, because of the fundamental theorem of calculus, we're taking the integral of a derivative, they undo each other, and we get this as a result here. All right, so I can also think of this, if f prime represents the rate of change, okay, so this is the rate of change here, then this quantity here, okay, the net change of f from when I go from a to b. All right, so we're going to use that idea here in answering these questions. This is, by the way, known as the net change theorem. This idea here. Okay, so in part A, it says, what does this integral from 0 to 20 represent? Well, r is a function that tells the rate of change of the oil leaking out. So this is going to represent then here, it's going to represent the number or amount of oil, number of liters, because we're doing liters here, oil that leaks in from 0 minutes to 20 minutes. Or you can also think of it in other words as the amount of oil that leaks during the first 20 minutes. Okay, so I can say the first 20 minutes because I'm going from 0 to 20, so that's the first 20 minutes. If my number, instead of being 0 here, if that had been 10, then it would be the amount of oil that leaked from 10 minutes to 20 minutes. All right. Now, the second part of this problem is you're supposed to find out how much oil leaks during the first 10 minutes. So I can write that as an integral from 0 to 10 of RT dt. And now I'm going to use the value that they gave me for r. They said r was 10 times e to the negative t. So 10 e to the negative t dt. So now I just have to evaluate that integral. So I have to find an antiderivative of e to the negative t. Well, if it's just e to the t, the antiderivative would be e to the t. But because I have a negative there, I'm going to get negative e to the negative t as the antiderivative. Negative 10 e to the negative t evaluated from t equals 0 to 10. All right, and when I plug those numbers in, then I get negative 10 e to the negative 10 minus negative 10 e to the 0. And so then e to the 0 is 1, and I have a negative here. So I have negative 10 e to the negative 10 plus 1, or that sometimes people will write that, put the positive number first. Or have the subtraction sign second, so that we have 1 minus 10 e to the negative 10. All right, I hope that helps.